Right everyone, now we are moving to the electronic instruments. So first we'll see the introduction about the electronic instruments. In the introduction, you'll see these electronic instruments we are using from from 19th century to now we are 20th century. So in this between, this popularity of electronic instruments are increases. So particular country is the ability or developing process based on this particular measurements, because while you are measuring the particular quantities, calculations, as well as estimate the unknown value, that is also shows our ability of a nation. So got my point. So this is a one of the electronic that means instrumentation is a one of the field to develop our country in the better manner. Okay, next one we have different type of measurements we have. The first one is related to the by mechanical means, that means mechanical quantity by mechanical means, the first one. So how to calculate the mechanical quantity? What are the mechanical quantities? Actually the mechanical quantities are pressure, for example. That is a mechanical quantity. So mechanical quantity is measured by this particular pressure is measured by pressure gauge or Borden pressure gauge, right? In the second one, by means of electrical, by means of electrical means. So yeah, in case of electrical measurements, the electrical measurements of the quantities of current and voltage with the help of the voltmeter. So potential difference, you can measure potential difference, that means voltage only, potential difference by means of voltmeter. Okay, clear. And then last one, by means of electronics. This is actually our chapter, by means of electronic instruments. So by means of electronic instruments, the speciality here, it is highly sensitive. That means a very small quantity is also measured with help of the amplification provided by the. So we are providing amplification. After amplification to measure the quantities. That is a speciality of electronic equipments. Okay, so this is about the three different categories. Now we are going to discuss about analog and digital instruments. Now we have two types of instruments. So first one is analog instruments, second one is a digital instruments. I will tell you what is mean by analog instrument, what is mean by digital instruments. For example, I have a meter. Okay, this particular meter have a pointer is starting from 0, some full scale deflection, for example. Okay, for example, some full scale deflection of 1 volt, for example. This is a voltmeter. Okay, so this particular meter indicated the value in the form of moving a pointer. Okay, this type of instrument you are call it as a analog instruments. What is mean by analog instrument? The pointer shows the value of the measured quantity. Those meters you are call it as a analog meters. In case of digital meters, this can be displayed in the form of digital form, in the form of zeros and ones. It is converted into 1 volt. So it is displayed in the form of zeros and 1 volt. It may be accuracy of maybe digital 3 digits or 4 digits after decimal point, in the form of digital form. Okay, so this is analog, and this is about the digital instruments. In case of digital instruments, in this particular display maybe LCD or LED display. You can either use the in this particular case display case. So now my question here, why are moving to analog instrument, digital instrument compared to the analog instrument? Analog instruments are having some advantages, digital instruments. That's why we are moving to the digital instruments now. We'll see what are the advantages of digital instruments compared to analog instruments. So advantages of digital instruments compared to analog instruments. We'll see advantages now. So in that case, the first one is easy reliability. Easy readability means that, for example, in this particular case, your pointer is deflecting from the 0 to some position. It is a 1 means that it is a 0.1, 0.2, some and so on 1. So while you are measuring, you can do calculated each and every line, indicated, and see in the without parallax error find out the value. But it was somewhat difficult, but it can be measured. In case of digital, we can see the value directly. So easy to readability. Okay, reading the value is easy readability. Okay, next, the second point is a greater accuracy. Accuracy means that while you are measuring this analog quantity, we have, for example, you want to measure 0.01 volt. I want to measure. We have a 2 meters here. In case of analog meters, it is difficult to measure 0.01. But in case of 2 digits digital meter, it can be able to measure 0.1 volt also. Got my point? That means that the accuracy is high. Greater accuracy. Next, third important one, better resolution. I will tell you the terminology related to the resolution, accuracy, all the definition later. So one more advantage is a better resolution. Right. Fourth one is a automatic polarity and zeroing. That means that in case of analog meters, if you are connected this particular analog meter from plus and minus, if you change the polarities negative and positive, it won't show the any value. That means that the pointer try to deflect it in the opposite direction, right? But in case of digital meters, if your polarities are reversed, it shows the negative only, but it shows the value. So automatic zeroing is also possible. That's why automatic polarity and zeroing, these are the advantages. Okay, maybe in the examination you may expect what are the advantages of digital instrument compared to analog instrument. They will give these 4 options, 3 options for example, and then fourth one is all of the above. You can choose all of the above is the answer. Okay, next we are moving to the next topic. Next topic is the functions of instruments. What are the functions of electronic instruments? We will see. So we have a 3 different functions of this this instrument, an electronic instrument. The first function is indicating instruments. Indicating. So we'll see what is mean by indicating instruments. You know, just now I mentioned that voltmeter and ammeter. So what a voltmeter indicated that voltage and ammeter indicated that current. So these are the instruments which indicate the instantaneous values. So that means, for example, I connected this particular supply, this particular voltage signal to the voltmeter. Okay, this voltage signal I connected some particular voltmeter. So this voltmeter shows the value at the time of instantaneous value present in the quantity. That means at particular instant they calculate the value. For example, it will be 1 ampere or 2 ampere, like that. So those instruments are indicated the instantaneous values. That is important point. Indicate instantaneous values. Okay. Okay. It indicated the instantaneous. Examples for this indicating instruments are voltmeter, ammeters. Okay, these are the examples for indicating instruments. Now second one, recording instruments. Recording instruments. So we'll see what is meant by recording instruments. In the case of instantaneous indicating instrument, it indicate the value after switch off the power supply. For example, this voltmeter is connected to the supply, it shows the value. Once you disconnect the particular voltage, what will happen? It will be, reading will be 0. That is, come back to the pointer, come back. Otherwise digital readout is a back to the indication, back to the 0 position. Okay, so in case of recording instrument, they are using this particular indicating instrument connected like a pen. For example, I will show the diagram here. Okay, see here, in this particular recording instruments, the graph will be attached to the pointer. Whenever pointer will be deflected, this particular graph draw the bar. Whenever the particular graph draw the bar, it value is stored in the form of graphical representation. In case of some industries, they are using the graphs to record the value for particular. For example, today is at 12 o'clock. What is about the reading? Today after 1 p.m. what about the reading? Every reading, every instant, graph is stored the value in the form of graphical representation. That type of storage is possible in case of recording instruments. Okay, so different type of recording instruments we have. The first recording instrument is a null type, that is it can be comparison basis. The first type is a null type instrument. That is a example which is operated on basis of which is operated basis on comparison. Okay, next, second type is a galvanometer type. So which is operate on the deflection type. So which operate on deflection type. Okay, this is about the recording instruments. So in the examination, you may expect they will ask the question, the example for indicating instruments. You can say that voltmeter, ammeter is an example for indicating instrument. What about the example for recording instruments? The recording instruments examples are recording voltmeter and recording ammeter. Example is a recording voltmeter and ammeter. Those are the examples. Okay, you may expect each and every point is in the examination. Next type of instrument is a integrating type. So in the case of integrating type, actually recording instrument, it records the instantaneous value, what particular instant, what about the value. But integrating instrument, it integrate the past value plus present value. That means a summation. Okay, the best example is a energy meter. Energy meter is an example for integrating instrument. That means in case of power, for example, I'm using the power consumption today is a 1 watt. Tomorrow one more 1 watt I consume. What about the total power consumed by yesterday and today? 2 watt. That means that it can be summation from the previous value, integration from the previous value to present value. Then only monthly current bill we will get. Got my point? That means every month it is included the value from the first 1 to 30 days. All values are summation. You will get the total value. That is example for integrating instruments. All of you clear about the integrating instruments? What is the example? Energy meter is an example for integrating instruments. Energy meter. Okay. Next we are moving to the next electronic versus electrical instruments. So what exactly the both electrical and electronic instruments advantages we'll discuss. In case of electrical instruments, they measure the quantity without any amplification. Okay, without any Amplification directly can measure the values of voltage and current with help of the instruments, electrical instruments. In case of electronic instruments, it can be measured after amplification of signal if it is required. So we have some advantages of electronic instruments compared to electrical instruments. Those instruments are, we'll see. Okay, so first point we'll see. The first point here, in case of electronic instruments, amplifying the signal, just now I mentioned, amplifying signal and measured. So in case of amplification, advantage is it can be measured small quantities also, small quantities, because a small quantity can amplifying the signal and then measure the value. So that is the first advantage. It can be measured very small quantity, that means low amplitude values quantities, low amplitude signals. Next, second important point, it has a very high sensitivity because it measured very small quantities. It is also very high sensitivity. So because of very high sensitivity, okay, whenever it is a high sensitivity, whenever it is possible, the input impedance is very high. Whenever it is a high sensitivity, the input impedance is high, increased. It means that loading effect also decreases. Very high input impedance, then loading effect will be decreases. Loading effect. Got my point? So this is one more advantage of electronic instrument. After that, third advantage is they have a greater speed. Speed is also greater. Okay, greater speed, as well as faster response and flexibility. Faster response and flexibility. Okay. Fourth, it can be monitor from remote signal. Okay. Monitor remote signals. Okay, these are about the advantages, comparison from analog versus electrical instruments. Okay, next we are moving to the essentials of electronic instruments. Okay, you got some idea about still now why you are using electronic instrument. Now we are moving to the what is the essential components is required to measure the to construct the electronic instruments. Okay, we have three different quantities, three different instruments are required. The first one is a transducer, second one is a signal modifier, third one is a indicating instrument or indicating meter is required. So first one is a transducer, we'll see. Okay, already I explained in the transducer. We have a last chapter number 7. I explained total entire discussion of transducer. From that, what is mean by transducer. Transducer converts non-electrical quantity into electrical quantity. I'm saying about the electrical transducer. So what electrical transducer is doing, it converts non-electrical quantities, to electrical signal. Okay, that is a transducer. That means that, for example, I want to measure the pressure. So pressure, I am using the strain gauge. Pressure is converted into the form of resistance and then converted in the form of electrical signal. Okay, it is connected to signal modifier. Okay, it is connected to signal modifier. Now you will see what is mean by signal modifier. See, signal modifier. The signal modifier means that it is a amplification, or if you, for example, I convert the signal very low amplitude value. I got here very low amplitude value. Whenever I got low amplitude value connected to directly meter, it cannot be show the value. Because it is a input is a very low amplitude, then it is converted into signal modifier, that is a amplifier. If I am connected to amplifier, then its signal is amplification. After that, it is connected to meter, it can be able to measure properly. So all the cases it may not be happen. Some cases very high magnitude available at the input, I need to reduce the amplitude, it is also possible. We have a clippers and clampers also used as a signal modifier. All these cases we are using the signal modifier. Okay, after signal modifier, modify the signal and connect it to the meter. The third one is indicating devices. So after amplification, what are the indicating devices? The indicating devices are voltmeters and ammeters. So this particular signal is connected to voltmeter and ammeter. Voltmeter and ammeters have measured the value and it will be display the value. This is about the actual electronic instrument is working. Clear? So three main components. After that, we'll see measurement standards. Okay, what I am explaining is every topic is mentioned in your syllabus. Each and pinpoint I am going to explain. So now we are moving to the measurement standard. So what are the measurement standards we have? We have 4 measurement standards. The first one is a international standards. International standards. So what is mean by international standards? We'll see. In case of I am going to design the particular equipment. That particular equipment is a standard equipment. That equipment obey the conditions given by the International Bureau of International. It can be obey the standards of International Bureau of Weights and Measurements. International Bureau of Weights and Measure. This is the organization they provided. It is in Paris. It is provided some standards. So you obey those particular standards. You design the equipment. Those equipments. It is a standard equipment. So that is called as international standards. International standard means that according to the international different countries they agreemented that International Bureau of Weights and Measurements in Paris, they agreed that some standards are required to design the particular meters. Those are called as international standards. Second one is a national, that is the second one is a primary standards. So primary standards. So these primary standards are related to the particular nation. For example, in our India, we are going to make some voltmeters, some meters. We are taking some standards based on our nation. So those standards, those primary standards are using. The primary standards are using to calibrate secondary instruments. So those are the secondary instruments are there. Those secondary instruments designed based on the calibration of primary instrument. This primary instrument standards based on the every nation is unique. Based on that particular nation or particular country, they design some rules and regulations. Based on that, they design the equipment. So that is a primary standard. Next one is a secondary standards. In the secondary standards, these secondary standards based on the laboratories. For example, in the laboratories, they can design the particular equipment or particular device. In that particular device, it's calibrated with the help of the primary standards, primary devices, and then they can use in the laboratory. Outside the laboratory, it cannot be using because they are designed for the laboratories only. Those instruments you are called as a secondary instruments. At the last one, fourth one, working standards. Working standards. In the working standards, in the industries only, in the industries only, they are using to industries they are using with their environment, with their standards. They are using with the help of the calibration of primary and secondary instrument. They design some instrument they can use within the industry. Outside industry, it cannot be possible to calculate the values with accurately, because they design their own. Okay, with the help of the calibration of primary and secondary, that is a important point. Those about the standards. This is about the part 1 video, and the part 2 video are going to discuss the remaining points. Thank you.